Hello everyone, I'm Ekim çetin. I'm a first year mechanical engineering student in Bilkent University, and today I'm going to try to present to you my Physics 101 lab project. In this project, I try to find a relationship between the hollowness of a cylinder and its moment of inertia. I used an inclined plane to drop the cylinders from and record their time with a video camera. By using this time, I found the different experimental values for the moment of inertia for each cylinder. So, to explain the experimental setup I used 5 different cylinders. Each cylinder had the same outer radius, and their inner radiuses ranged from 0% of the outer radius to 80% of the outer radius. I used 2 sticks as inclined planes, and I stacked the cylinders on top of those sticks and rolled them down. And then I recorded them with a video camera, found the time, and then I repeated this process 4 times. And then I took the average of these times in order to find a value that's riddled with the least inaccuracies. So, to get to the actual theory part of this experiment, I mainly relied on the conservation of energy principle, and then I calculated the potential energy that was then converted into linear and rotational kinetic energy while the motion was going on. I used these formulas to derive a formula that was based on the time it took for the cylinder to reach the ground, which looks like this. Before we get into the results, we can take a look at the experiment itself and some actual footage of the trials I conducted. Now that we inspected the experiment being conducted, we can take a look at the results. So I recorded the time using a video camera, and then I made a table of the recorded times and the moment of inertia calculated depending on it. The tables look like this. And depending on these tables, I made a graph like this. And comparing these experimental values to the theoretical value using this formula, I found a table like this showing the percentage differences between each. As you can see, the biggest percentage difference between the theoretical and experimental value is on the last one, which is the cylinder that has the biggest inner radius. And this could be because that the moment of inertia of the cylinder is higher and causes it to slip more on the inclined plane. So to discuss the errors that could be prominent in this experiment, we can say that some errors such as friction, inconsistencies in the cylinders used, deformations, air resistance, and the increased slipping caused by the increased moment of inertia of these cylinders can be taken into account, and these errors probably contributed into the percentage differences between theoretical and experimental values. In conclusion, I think it can be said that in spite of the errors present in the experiment still shows a positive relationship between the hollowness of a cylinder and the moment of inertia of it. We can say that the moment of inertia increases as hollowness of a cylinder increases based on the results we obtained, and by comparing them to the theoretical values of the cylinders, we found that our results, even though they were not perfect, they were consistent. I think these results and this experiment can present valuable insight to any physics or engineering department that deals with rotational dynamics.